Hi, I am Brent Mansfield, a research lab agronomist at X-Acto Inc. Whether you are in the industrial vegetation management, turf or ornamental, or the agriculture industry, the best way to control weeds and brush is by the use of herbicides. But have you noticed how your herbicide has not worked as you expected? Sure, maybe the weeds have developed genetic resistance, but a more likely answer is that the tank mix water did not cooperate with the herbicide. The mixing water is the largest part of the tank mix. Let's talk about how to improve the performance of the herbicide by talking about water quality. Let's take a closer look at water and two chemical properties, pH and water hardness. pH is a measure of how basic or acidic your water is. It is measured on a scale of 0 to 14. 7 is considered neutral. Anything below 7 is more acidic and anything above 7 is more basic, or otherwise known as alkaline. In a moment, I'll explain how pH affects herbicides and show you how to measure pH. The other property of water, which is easy to understand, is water hardness. Water hardness describes the mineral content in water. Water with a high content of dissolved minerals is considered hard water. You might know if the water in your area is hard. For example, the mineral crusting on the plumbing lines or the bags of salt for sale at the gas station. These are good indicators that there's hard water in your area. Examples of hard water ions or minerals are calcium, iron, magnesium, or aluminum. Water hardness is also measured on a scale with the following intervals. 0 to 60 ppm is equivalent to soft, 61 to 120 ppm is equivalent to moderately hard, 121 to 180 ppm is hard, and 181 plus ppm is very hard. Let's take a closer look at your herbicide and how the water properties, pH, and water hardness can affect the herbicide in your tank mix. It is important to understand the requirements of your herbicides so that performance is not compromised. Most herbicides, such as glyphosate and other weak acid herbicides, perform the best in slightly acidic water, while other herbicides perform best in alkaline water. Beyond pH affecting the herbicide, water hardness can dramatically affect field performance. When a herbicide is mixed with water, it chemically binds to the hard water minerals in the tank mix. Until those hard water ions like calcium and iron are neutralized, your herbicide performance can be reduced. Nearly every region of the United States has to deal with water, which is less than perfect for herbicide applications. This map shows how water hardness varies across the U.S. Water hardness not only varies from state to state, but within a state there can be significant differences. With a simple pH test, we can gain understanding into a pH and water hardness in order to adjust it prior to adding the herbicide. Here's how to do the test. First, make sure that your container is clean of any residue that can alter the results. Next, you submerge the strip into the container for 3 to 5 seconds. Then place the strip next to the scale and see the results. In the hard water sample, the pH is equivalent to 8.4, and the total hardness is between 400 and 800 ppm. So now we know that the pH and water hardness in our water sample is outside of the herbicide label guidelines. The best way to fix this is to utilize a water conditioning agent to adjust your pH. A water conditioner will also help water hardness by preventing the hard mineral ions from interacting or binding to the herbicide. At X-Acto, we manufacture a variety of water conditioners to fit your needs. Let's review. Understand the herbicide by thoroughly reading the label. Test the tank mix water for both pH and water hardness. Utilize a water conditioner for best results. Contact us today.